the Star Whisperer. The night sky stretched endlessly above the Atacama Desert, a canvas of twinkling lights that seemed to whisper secrets of the cosmos. In 1915, a Scottish astronomer named Robert Innes stood beneath this same sky, his telescope trained on a faint, unassuming star. He was a man driven by curiosity, a space master who sought to unravel the mysteries of the universe. Little did he know that his discovery would ignite a century-long quest, one that would captivate scientists and dreamers alike. He called it Proxima Centauri, the closest star to our sun, a mere 4.24 light-years away. It was a small, red dwarf, dim and elusive, invisible to the naked eye. Yet, in its quiet glow lay the promise of something extraordinary. Decades later, in the year 2016, a new chapter began. Astronomers at the European Southern Observatory huddled around their screens, their hearts racing as they analyzed data from a powerful telescope. They were chasing a hunch, a subtle wobble in Proxima Centauri's position that hinted at something unseen. The radial velocity technique, a method that measured the star's tiny shifts caused by the gravitational tug of an orbiting planet, had revealed a secret. Proxima B, an Earth-sized world circling its star in the habitable zone, the Goldilocks region where liquid water and perhaps life could exist. The discovery sent ripples through the scientific community. Proxima B wasn't just another exoplanet. It was the closest candidate for a second Earth, a rocky world that might hold the key to one of humanity's oldest questions. Are we alone? The star and its world. Proxima Centauri was no ordinary star, a red dwarf. It was smaller and cooler than the sun, its surface glowing with a faint crimson hue. Unlike the sun, which bathed Earth in warmth from 93 million miles away, Proxima Centauri's habitable zone was far closer to its surface. A mere 0.05 astronomical units, about 20 times closer than Earth's orbit. This proximity shaped Proxima B's existence in ways both wondrous and perilous. Dr. Elena Martinez stood at the edge of the observatory, her breath visible in the chilly desert air. She was a planetary scientist, one of the many who had devoted their lives to studying Proxima B. Her colleagues called her the Star Whisperer, for she seemed to hear the stories that stars told through their light. Tonight, she was preparing for a new observation run, her eyes fixed on the data streaming in from the James Webb Space Telescope, JWST. The telescope, a marvel of human ingenuity, was humanity's best hope for unlocking Proxima B's secrets. Elena's fascination with Proxima B began years ago. When she first read about its discovery, the planet was tidally locked, one side perpetually bathed in the star's dim light, the other shrouded in eternal darkness. This created a world of extremes, a sun-scorched day side, a frozen night side, and a thin strip of twilight, the Terminator line, where conditions might be just right for life. But life on Proxima B faced daunting challenges. Proxima Centauri was a restless star, prone to violent solar flares that unleashed torrents of X-rays and ultraviolet radiation. These outbursts could strip away a planet's atmosphere, leaving its surface barren and exposed. Elena imagined Proxima B as a cosmic puzzle, a world that defied Earth's rules of habitability. Could life exist in such a harsh environment? On Earth, extremophiles, organisms like Deinococcus radiodurans, thrived in radiation-soaked deserts and deep-sea vents. Perhaps Proxima B harbored its own resilient life forms, hidden in subsurface oceans or shielded caves. The thought thrilled her, but she knew that answers lay beyond the reach of Earth's telescopes, distorted by atmospheric interference and light pollution. The eye of the cosmos, high above Earth, at a stable point 1.5 million kilometers away, the James Webb Space Telescope floated silently. Launched as a successor to the Hubble Space Telescope, JWST was no ordinary instrument. It was a time machine, a cosmic eye designed to peer into the universe's deepest secrets. Its 6.5-meter primary mirror, composed of 18 gold-coated hexagonal segments, gleamed like a golden honeycomb. This mirror, more than twice the size of Hubble's, could capture the faintest glimmers of light from distant stars and galaxies. A sun shield, layered like a delicate silver sail, kept the telescope's instruments at a frigid minus 233 degrees Celsius, ensuring that its own heat wouldn't interfere with the faint infrared signals it sought. Unlike Hubble, which orbited Earth and observed invisible and ultraviolet light, JWST was designed for the infrared spectrum. This allowed it to see through cosmic dust, revealing hidden stars and planets, and to study redshifted light from objects stretched by the universe's expansion. Its instruments, the near-infrared camera and IR cam, the mid-infrared instrument MIRI, and the near-infrared spectrograph and IR spec, were tools of unparalleled precision, capable of analyzing the atmospheres of distant exoplanets like Proxima B. Elena's team had secured precious observation time on JWST, a rare opportunity to study Proxima B's atmosphere. The planet's proximity to Earth made it an ideal target, but its faintness posed a challenge. Even JWST's powerful mirrors struggled to capture enough light to reveal the planet's secrets. Yet Elena was undeterred. She believed that JWST could detect traces of water vapor, methane, or other biosignatures in Proxima B's atmosphere. If it had one, the planet's mass, roughly 1.17 times that of Earth, suggested it was rocky, like our own world. But without a protective magnetic field, its atmosphere might have been eroded by Proxima Centauri's relentless flares. A world of contrasts. In her dreams, Elena walked the surface of Proxima B. She pictured a landscape of stark beauty. Crimson skies lit by the dim glow of Proxima Centauri, rocky plains scarred by ancient impacts, and perhaps, in the twilight zone, pools of liquid water shimmering under a perpetual sunset. The Terminator line fascinated her most, a narrow band where day and night met, where temperatures might be mild enough for life to take hold. But the planet's tidally locked nature created challenges unimaginable on Earth. The day side burned under constant radiation, while the night side lay frozen, locked in an icy grip. The stars' flares were the greatest threat. Red dwarfs like Proxima Centauri were notorious for their volatility, unleashing bursts of energy that could sterilize a planet's surface. Elena's research focused on whether Proxima B could retain an atmosphere despite this onslaught. A strong magnetic field, like Earth's magnetosphere, could deflect stellar radiation, preserving the planet's air and water. But detecting such a field required data that only JWST could provide. Elena's team pored over the telescope's early observations, searching for clues. The data hinted at a thin atmosphere, possibly rich in carbon dioxide or nitrogen, but the signals were faint and inconclusive. They needed more time, more light, more patience. Elena often thought of Proxima B as a cosmic survivor, a world that had endured billions of years of stellar tantrums. If life existed there, it would be unlike anything on Earth, perhaps microbial colonies huddled in subsurface oceans, or organisms with biochemistries adapted to withstand extreme radiation. The quest for life. The discovery of Proxima B had sparked a global fascination, not just among scientists, but among poets, artists, and dreamers. It was the closest. Elena's research extended beyond Proxima B to other red dwarf systems. Stars like TRAPPIST-1, with its 7 Earth-sized planets, offered similar opportunities to study life in extreme environments. But Proxima B remained special. Its proximity to Earth made it a beacon, a target for future missions that might one day send probes to explore its surface. Elena dreamed of such a mission, a fleet of tiny spacecraft, propelled by laser sails, crossing the 4.24 light-years to Proxima Centauri. The Breakthrough Starshot Initiative, a bold plan to send probes to the Alpha Centauri system, was still in its infancy, but it fueled her hope. The Red Dwarf Secrets. Proxima Centauri itself was a star worth studying. As part of the Alpha Centauri system, alongside the sun-like stars Alpha Centauri A and B, offer a unique laboratory for understanding stellar behavior. Red dwarfs were vastly different from the Sun, smaller, cooler, and far longer-lived. Their faint glow made them hard to observe, but their abundance in the galaxy made them critical to the search for life. Elena's team studied Proxima Centauri's flares, mapping their frequency and intensity to understand their impact on Proxima B. Each flare was a reminder of the star's power, a force that could both create and destroy the condition for life. The planet's potential magnetic field was a key focus. On Earth, the magnetosphere shielded life from solar wind and cosmic rays. If Proxima B had a similar shield, it could retain an atmosphere capable of supporting liquid water. Elena's team used JWST spectrograph to search for signs of atmospheric gases, hoping to detect oxygen, water vapor, or methane, molecules that could hint at biological processes. The data was tantalizing but incomplete, a puzzle with missing pieces. The light of possibility Elena Martinez sat in the control room of the Atacama Observatory, the hum of computers filling the air like a chorus of distant stars. The latest data from JWST had sparked a fire in her team, a flicker of hope that Proxima B might hold traces of water vapor. But hope was a fragile thing in the world of exoplanet science, where every discovery came with a dozen new questions. Elena's colleague, Dr. Rajesh Patel, leaned over her shoulder, his eyes scanning the spectral lines on the screen. Rajesh was an astrophysicist with a knack for finding patterns in chaos, and his enthusiasm was infectious. "Look at this, Elena," he said, pointing to a subtle peak in the data. "It's faint, but it's consistent with water. If we can confirm this, it's a game changer." Elena nodded, her mind racing. Water vapor could mean an atmosphere, and an atmosphere could mean a chance for life. But Proxima B was no Earth. Its tidally locked nature and the relentless flares from Proxima Centauri created a world of extremes that challenged every assumption about habitability. She thought of the planet's terminator line, that narrow band where day and night blurred into twilight. Could life thrive there, in a place of eternal dusk? Or perhaps beneath the surface, in hidden oceans shielded from the stars' wrath? The team's excitement was tempered by the limitations of their tools. Even JWST, with its 6.5-meter mirror and infrared precision, could only glimpse Proxima B indirectly. The planet was too small, too faint, to be imaged directly. Instead, they relied on spectroscopy, analyzing the star's light as it filtered through Proxima B's atmosphere during a transit. Each dip in the spectrum told a story, of molecules, temperatures, and pressures, but it was like reading a book with half the pages torn out. The team of Dreamers Elena's team was a mosaic of brilliance. There was Rajesh, the data wizard who could tease meaning from the faintest signals. Then there was Dr. Mei Lin, a geochemist who studied Earth's extremophiles to imagine what life on Proxima B might look like. Mei often spoke of microbes in Earth's deep-sea vents, organisms that thrive without sunlight, fueled by chemical energy. If life exists on Proxima B, she'd say, it won't need a cozy Earth-like environment. It'll be tough, adaptive, maybe even alien in ways we can't imagine. The newest member of the team was Liam Carter, a young engineer who had helped design JWST's Sun Shield. Liam was barely out of his PhD, but his passion for the telescope made him indispensable. He'd spent years ensuring that the Sun Shield's 5 delicate layers could protect JWST's instruments from the sun's heat, keeping them at the minus 233 degrees Celsius needed for infrared observations. "It's like wrapping the universe's most expensive camera in a cosmic blanket," he'd joke, but his pride in the telescope was palpable. Together, they formed a unit bound by a shared dream, to uncover the secrets of Proxima B. Their work wasn't just about science. It was about pushing the boundaries of what it meant to be human. Proxima Centauri, as the closest star to Earth, was a beacon of possibility. Its red dwarf nature, smaller, cooler, and longer-lived than the Sun, made it a perfect laboratory for studying the most common stars in the galaxy. Red dwarfs accounted for nearly 3/4 of the Milky Way stars, and many hosted planets in their tight habitable zones. If life could exist on Proxima B, it could exist on countless other worlds. The star's fury Proxima Centauri was a star of contradictions. Its dim glow belied a fiery temper. With solar flares, it could unleash radiation 1,000 times more intense than Earth's Sunday. Elena often compared it to a petulant child, capable of quiet moments but prone to explosive tantrums. These flares pose the greatest threat to Proxima B's habitability. Without a strong magnetic field, the planet's atmosphere could be stripped away over billions of years, leaving it a barren rock. Even if an atmosphere survived, the radiation would challenge any life forms, breaking chemical bonds and disrupting the delicate processes needed for biology. May's research offered a glimmer of hope. She studied Earth organisms like tardigrades and Deinococcus radiodurans, which could repair DNA damage caused by radiation. Proxima B's life forms might have evolved extreme resilience, she theorized. Imagine microbes with supercharged repair mechanisms, or biochemistries we've never seen. The dark side of the planet, shielded from flares, could be a refuge. Or maybe there are subsurface oceans, like on Europa, where life thrives in darkness. A new dawn, one crisp morning. As the sun rose over the Atacama Desert, Elena received a message from her team. JWST had captured a new spectrum from Proxima B, a faint but promising signal. The data suggested the presence of water vapor, a trace that sent her heart racing. It wasn't proof of life, but it was a step closer. She imagined a world where microbial life clung to existence in hidden oases, or where subsurface oceans teemed with strange, resilient organisms. The possibility was enough to keep her going, to fuel her late-night calculations and her dreams of distant worlds. Proxima B was more than a planet. It was a mirror reflecting humanity's hopes and fears. It challenged scientists to redefine habitability, to imagine life informed beyond Earth's blueprint. As Elena prepared for the next observation run, she felt a connection to Robert Innes, the man who had first glimpsed Proxima Centauri's light. Like him, she was driven by a need to understand, to reach out to the stars and ask, "Are we alone?" The James Webb Space Telescope, with its golden mirror and infrared eye,